Okay, this is the test corrections for hypothesis test or inferences, actually I should say, for proportions. Remember, you need to write down everything and turn that all in. And also the important thing is to make sure you actually learn and pick up any details you may have missed. So please pay close attention as we go through these videos. And this will be question 1. A certain company makes 3 grades A, B, C of a particular electrical component. Historically, grade A components have a 2% defective rate, while grade Bs have a 5% defective rate, and grade C have a 10% defective rate. Since grade A components are less likely to be defective, the company can charge more money for those components than it can charge for grade B or C. Similarly, the company can charge more for grade B than it can for grade C. Recently, the company found a batch of components in a warehouse that were known to be of the same grade, but the grade was not labeled on the components. To determine the grade A, B, or C, the company selected from that batch a random sample of 200 components, which contained, when they checked it, 16 defective. Construct and interpret a 95% confidence interval for the proportion of defective components in the batch. Well, we need to start off every single time, and this is really important, got to define our parameter. Let P, and you can use P as opposed to PO. P is the true population proportion of defects in the batch of electrical components. All right? And we don't know whether that's A, B, or C, but it's just the proportion of defects. Our conditions, well, they took a random sample because they told us that. All right. And that was right up here. So that was given, and then we just need to say random sample. Really, it's a random sample of 200. N is less than 10% of the population. It's reasonable to assume that there are at least 2,000 electrical components in the batch. Then we need to check our normality. And normality here has to be that the counts are greater than 10. You did not have to write NP and NQ, that wasn't necessary. But 16, the number of defects was greater than 10. And then 184, which was 200 minus 16, was also greater than 10. So the sample is large enough to use the normal approximation, or the distribution of the sample proportions is approximately normal. All right. And we need to know P hat equals 16 over 200, which is 0.08. And Q hat is 1 minus that, or 0.92. And so we have our formula, P hat plus or minus Z star, P hat, Q hat, and then we need to plug in. Well, here's P hat, and we just calculated that at 16 over 200, or 0.08. So this is 0.08, and this is 1 minus 0.08 over 200. Z star is going to come straight from the calculator. Second vars, inverse norm, parenthesis, 1 minus 0.95 divided by 2, mean of 0, standard deviation of 1. And we end up getting 1.9599 or 1.96. All right. So let's go ahead and run this test, and we're going to get our interval. Because ultimately what we are constructing is we're constructing a 95% confidence interval, and we're looking for a lower bound and an upper bound with 95% in the here, and we happen to know that our P hat 0.08 is going to be exactly in the middle. So stat test, 1 proportion Z test, and our oh, I'm sorry, I should have gone stat test, 1 proportion Z interval, because we're running a Z interval. So that's letter A down here. And our X, the number of defects was 16 out of 200. And we want a 95% confidence interval, so 0.95. And we end up getting a lower bound of 0.0424 and an upper bound of 0.1176. And we need to have our concluding statement, which is we are 95% confident that the true population proportion of electrical defects lies within the interval. Okay, and if we were scoring this first section up here, the conditions and the definition, that gives you 1 point. The actual work in successfully calculating the confidence interval gives you a point. Your conclusion about the confidence interval gives you a point. And then we have part B, which will get to the 4th point. Does the interval in part A allow the company to clearly determine the grade of component that was produced in the batch? All right, well, we know that it was 0.04 to 0.24. And we also know grade A is 2%. So 2% is below it. It cannot be grade A. On the other hand, grade B is 5% and grade C is 10%. And both 5% and 10% lie within the interval. So technically, we need to say that A does not lie in the interval, but B and C are possible, so we cannot determine. So because 2% does not lie within the interval, the batch cannot be grade A. So we needed to address that. And then we need to say both both 5% and 10% lie within in the interval. Thus, we cannot determine whether or not the batch is B or C. All right, and you really needed to have all of that. We were a little bit lenient on that, but you need to say that we exclude A, and then B and C, we could not tell which one it was. All right, so that's how you get your 4th point. This is your stat sensei, and I'll see you on the next video. Thank you so much.